Hi everyone, let's go ahead and go over Module 8, Day 2 test review. So on this one here, I am going to take this word problem and write out an equation. So on this equation, I see that Maria borrowed $400 from a short-term loan. The amount after 2 months is $920. If she waits 3 months, the repayment amount rises to $1,380. So we have to write a function that models how much Maria owes after X months. So she borrowed $400. 2 months later, she's going to have to pay $920, and if she waits till 3 months, then she has to pay $1,380. So when I look at these three different ordered pairs, at 0 months, it was $400. At 2 months, it was $920. And at 3 months, it was $1,380. Now, this 400 is important because it's my initial value. It's going to be what I replace A with. So I'm going to replace A with 400. But to find the B value, I need to look at the X value. So this is 0. This is 2. That's a difference of 2 months. The ones that I want to use is when there's only a difference of 1. So from 2 months to 3 months, only a difference of 1. So I'm asking myself, how did they get from 920 to 1,380? What did they multiply to get 920 times what makes 1,380? To find that value, we divide 1,380 by the previous y value, by 920. So you always take any y value and divide it by the previous one. That's going to give me 1.5. So what did they multiply by? 1.5. That's our b value. So when I write my equation, I have y equals the initial value of 400 times our b, which is our common ratio, 1.5, to the power of x, because we don't know how many months she's going to keep that loan. All right, let's go on to the next one. So on the next one, Jacob took out a loan to purchase a scooter, and it was for $180. Now, when he took out that loan for $180, they told him that after 2 weeks, he would have to pay $405, or after 3 weeks, it would be $607.50. Okay? So when we're looking at those ones, we want to ask ourselves, which one is 1 week after the other? So we're going to be looking at week 2, which is $405. And we're going to be looking at week 3, which is $607.50. Okay? So how did they multiply to get from 405, or what did they multiply, to $607.50? So we take $607.50 divided by 405, and we will get 1.5. So our equation is y equals the initial value, our y-intercept of 180, times 1.5 to the power of x. All right, let's go on to our next task. And on the next task, we are looking at tables. So when I'm looking at the tables, again, look at the y values to make sure that it's going up by ones. So from 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. As long as the x values are going up by ones, we can find the multiplication part of any of the two y values. So if I'm looking at this, I have 128 divided by 512 is 0.25, or it can also be written as 1/4. Okay, 128 times what makes 32? So 32 divided by 128 is 0.25. So that's our common ratio. That's our b value. Now when we're writing our equation, we have y equals, to find our a value, it is always where y is paired with 0 for x. This is our y-intercept. That's our a value. So y equals 512 times our common ratio of 0.25 or 25 hundredths to the power of x. Now, is this one a growth or decay? So when we're looking at the y values, notice that it goes from 512 to 128 to 32. So those are decreasing. When those are decreasing, this is exponential decay. When it's exponential decay, b is between 0 and 1. So if b is between 0 and 1, make sure that your b value is between 0 and 1. All right, so let's look at this next one. What's our y-intercept? It's not going to be the first one on the table unless the first one on the table has a 0 for x, and in this case it does. So our y-intercept is 0, 0.1. So when we write our equation, we write our y-intercept first. So y equals 0.1. To find the common ratio, we are going to look at these values here. What are they multiplying 0.1 by to get 0.2? What are they multiplying 0.2 by to get 0.4? What are they multiplying 0.4 by to get 0.8? Now you can use any of these y values and divide it by the previous value. So if I do 0.2 divided by 0.1, I get 2. If I do 0.4 divided by 0.2, I get 2. So my common ratio is going to be 2. All right, look at our y values. Are the y values getting bigger as they go on, or are they getting smaller? Well, they're getting bigger. So in that case, it is a growth. When it's a growth, b is greater than 1. So make sure that your b value is greater than 1. All right, let's go on to our last task. Here we have task 6. Now on this one, I've broken it up into smaller steps. So just to kind of give you an idea of what we're looking at. So if I were to ask you to hold $10 for me, and you later gave them back to me, but you gave me 15. You actually gave me $5 extra. I would call that, maybe that's interest, okay? So how did I get that $5 extra? Well, I would take 15 minus the 10 that I asked you to hold, and that $5 extra is what I'm looking at with interest. So when we look at David investing $9,000 into a simple interest account, he put that $9,000 in there. He left it there for 9 years. After 9 years, they gave him back $14,320. So what's the extra that they gave him? That's called interest. There's a percentage that they held, or that they gave him on top of the money he let them hold on to. So we take his current balance minus the amount that he asked them to hold, that he invested, and we find that interest. So when we subtract those two, we get $5,320 for interest. Okay? All right, so now let's go on to number 2. Now on number 2, Riley had $6,000 in an account that paid 3.5% interest, compounded semi-annually. What was the amount in her account at the end of 3 years? And then what was the value of interest that Riley received after 3 years? Well, let's answer one question at a time. Let's find out how much money she had at the end of 3 years. So we're going to take the equation and we're going to use compound interest. We start with our initial value. We would like 100% of that back, and that's 1. And then we add the interest that they promised to give us, which is 3.5%. So divide 3.5 by 100 to get 0.035. Then it's compounding semi-annually. Semi-annually means twice a year. Now up in the exponent, how often are they looking at it per year? Is 2 times per year. How many years are we going to leave that in the bank? Riley's going to leave that there for 3 years. Okay, so once we have our equation written out, we go ahead, plug that into our calculator. The whole thing into the EOC calculator. And I've cheated just a tad here to make sure that I have that. She will have back $6,658.21. It actually had a 4 as the number after 21. Now remember, if it's 5 or more, we would round up. But anything below 5, we stayed the same. So it stays at 21. Now that was the first question. That's how much money she has at the end of 3 years. Now originally she invested $6,000. So we are going to subtract off $6,000 to find the amount of interest that she had. So we've got the interest that Riley earned on top of the $6,000 was $658.21. Okay, so that's what I'm talking about when we get to interest. Now down here at this problem, this is when Teresa deposited $12,000 into 2 different accounts. So we have 2 different accounts that we're looking at. We're looking at account A and we're looking at account B. Account A earns 2.9% simple interest. Account B earns 2.9% compounded annually. So for annually, that means that N equals 1. The bank looks at that account 1 time per year. So simple interest will give us A equals 12,000 times 1 for 100% of the money back, plus the interest that they offered, which is 0.029 times the number of years that it's going to be in there, which is 10. Okay. Our compound interest equation is A equals 12,000 times 1 plus 0.29 thousandths divided by 1 time per year to the power of 1 times 10 years. All right, so we've got to plug those into our EOC calculator to get our value. I've gone ahead and already had those here because I didn't have my EOC calculator with me. Oops. Let's go ahead and here, I'll just rewrite that. So let's put that back. So I have $15,480. Now that's how much she got back from Bank A. From Bank B, she got $15,971, and this one here, I believe, was 106 exactly in the calculator. This 6 is 5 or more, so it tells me to round up from 10 cents to 11 cents. So now to find the difference of these 2 accounts, we're just going to subtract them. So I'm going to take $15,971.11 and I am going to subtract $15,480, which she got from account A. And our answer is $491.11 more interest in account B. Okay. And we've talked about that. Compound usually is going to give us more in the long run than simple interest. So it probably would have been better if Teresa would have deposited all $24,000 into a compound interest account. But that's what we're looking at this for. So when we do our own in the future, we know what to watch out for.